All right, we are here. It is just after lunch. Your belly should be full. You should be ready to go. You should be so excited to be in your favorite class. And if chemistry is not your favorite class, do not ruin my dream and tell me. Right now, if you guys could show me your lovely faces on your video, I would appreciate it so much. I want to see what your lovely faces look like. I'm not used to teaching and not knowing what you look like. It makes me sad in my heart space. Okay. So, $1 million question. I have my name generator up on my phone per usual. So if no one volunteers, I will call on you, but ... What should you have done already for today's lesson? What should you have done already before showing up? Go ahead.
Attendance.
Attendance link? Oh, a gold star to you. Yes, exactly. What else should we have done from the learning plan? Oh, I love that you said attendance first. Ooh, it's so important. I love it. Okay. From the learning plan, let's see. I can spin the wheel. It's cool. Kevin. Good afternoon, Kevin.
QC 1.3 in the notes.
QC 1.3, QC 1.4 should all, well, QC 1.4 is today, but QC 1.3 should be done. You should also have the video notes. Yes, the video notes, okay, over classification of matter. So when I come to these classes, again, just to explain again, I'll say it a bunch of times, I assume you've done the notes. So I'm not like lecturing like a lecture. I am reinforcing the more difficult concepts and making sure I am here to answer your questions. Does that make sense? So I am taking the responsibility of making sure you have access to more explanation of more difficult concepts. You are taking the responsibility of watching those short videos, taking your notes, and being semi-exposed to the content. I don't expect you to understand everything you wrote down. That is not like very rarely does someone understand something on the first exposure. But when you get that first exposure, it allows me to use the stuff that you've seen to create new attachments and make it make sense in your brain space. Okay. So I'm just reiterating that because I've had some people tell me that they've not been watching the video notes. So when they get to the quick checks, they're not scoring well. So that's something I wanted to say. For those of you who are asking where the attendance link is in Canvas from now on and forever. There's more than one of you asking me. And again, if you ever want to ask me a question, don't feel comfortable making it public. Just send it to me privately. I will address it. I won't out you as much as possible. So thank you for the people who anonymously asked me. It is in Canvas, remember, right by the Zoom link. The attendance link is right above the Zoom links, okay? All righty then. So we've watched our notes. We did the attendance link. You have a QR code on your screen. Yes, thumbs up if you can see my screen. Make sure it is working properly. Love that. You need to do a screen grab or video or take your phone and be like, right, to figure out how to get there. I'm going to put you all in a breakout room. This is just making sure you understand the basics of classification of matter. It does not go into the types of heterogeneous solutions. We're going to do that very briefly on our own. But this warm-up activity will help you get the basics of what you should have remembered from 8th grade science, okay? Good. And 8th grade was a long time ago, so I understand, which is why we're doing activities, yeah? Okay, so get the link going. I also have it there if you need to type it. I'm gonna open up the breakout rooms, so you will have access to a breakout room, okay? Do not click the link until you have this up and going. I'm gonna give you literally like 2 minutes on the clock to do it, okay? So opening the breakout rooms right now. Okay, go there for 2 minutes. Do the thing. Okay, lovelies, I know that was a really fast 2 minutes. It always goes by faster than you think when you're timed. It's like if you play music and you play with a metronome, you swear to God the metronome is messed up, and it's not, it's you, but that was maybe just my experience. It's fine. But the 2 minutes has passed, so I'm gonna ask some questions. Claire Bear, Claire, where you at?
Hello.
Hi, what's the difference between a pure substance and a mixture?
So a pure substance is something that cannot be separated and is on the periodic table. And a mixture is can be like physically separated and is not uniform. Like there's two different things in it.
Yeah, there's two different types of mixtures, right? There's the non-uniform and the uniform, and I hear you touching on that. The non-uniform is the heterogeneous or the hetero word, meaning different, and then homogeneous with the homo prefix, meaning same, right? So that's where those come from. So same composition or different composition. That's what those mean in their Latin roots, okay? So that was perfect. I love that. Thank you so much for your answer. You said it with confidence too. It was like the best way to answer. I don't care if you guys are like 10,000% wrong. You answer like that and I'm gonna be like, oh, go. I love it. I love confidence, okay? So Adia. Are you here,
Yes.
sweetheart?
Yes.
There you are. Hi, good morning. Good afternoon. Wow, it's already afternoon. Good afternoon. What is the difference between an element and a compound?
A compound is basically like a combination or like chemically bounded elements.
They're chemically bound in a fixed ratio, right? That fixed ratio word is going to be really great for you to remember. It's represented by a chemical formula. The reason we use the word ratio is because it's actually mathematical, right? You can't just say water is hydrogen and oxygen, because then it could be H2O, it could be H3O4, it could be H10,002. Like you could have any combination ever, and that's not water, right? It's one specific combination in a ratio, chemically bonded. I'm so happy you said chemically bonded. Makes my heart happy. I can tell you listen to the notes. Thank you so much, my friend. Okay. Last question. And this is a bonus question that was not in the warm-up. So if you struggle, just know you're a normal human. But Madison, you get the bus thrown over you today. Madison, you ready for some bus time?
Oh
Okay.
boy,
Do you know the two types of heterogeneous mixtures?
I do not.
You do not? That's okay. Okay, so when you have medicine, okay, in a bottle, it tells you to shake it. Do you know what they call those on the side of the bottle? Have you seen that before?
No.
No, okay. So they call that a suspension. So when I say suspension, what does the word suspension make you think of? Like anything, not in science, it's suspension, like that word. What do you think of? There's no wrong answer here.
Something?
So what is
Like
it?
suspended from school?
Suspended from school means you're absent from school. You are being held somewhere else, right? You are not allowed to come here. Yes, that is actually a great analogy. And I love that you're playing along with me and letting me pick on you a little bit. So thank you for letting me ask you weird questions. Okay, you're good, baby girl. So suspensions are things, and colloids are two different types of heterogeneous mixtures. Colloid is a word you may not have heard. Suspension we've heard in a lot of different ways. A lot of people who've had prescriptions know it because it says, this is a suspension of amoxicillin or whatever. Shake the bottle, keep it in the fridge, etc. So very briefly, before we get started, that's the one thing I'm going to touch on before we do our Kahoot, which is what I have for you. I have this, okay? We're going to worry, but don't worry about the Tyndall effect word at the moment. I want you all to explore this with me for just a second, okay? So the word solution, okay? It is not like, here's the answer to the problem. In chemistry, a solution is a homogeneous mixture, period. You can use them interchangeably. A solution, homogeneous mixture. Usually we think of aqueous solutions, but the fact that we have to say the word aqueous, which you will get to in a second, means that there can also be non-aqueous solutions. Otherwise we wouldn't have to designate it, right? So any homogeneous mixture is a solution, okay? Colloids and suspensions are different. So a suspension, another great analogy for a suspension is a snow globe. Who's ever played with a snow globe? This is one that most people have seen or played with. Okay, I know it's also very Euro-American centric, so if you're not from this part of the world, I apologize for not being culturally appropriate, but I figured the example worked for most of us, okay? Snow globes, you shake them, and what happens? Right? All the snow comes up, and then you set it on your desk. What happens after you set it on your desk? Does all the snow stay in the air? No, what happens? Show me with your hands. What does it do? Everyone show me with your hands. Be active with me. Yes, I know, Oliver, that looked painful, buddy. I'm so sorry. Okay, it falls down, right? It falls down. So over time, gravity pulls on the particles because they're big enough to be suspended for a second temporarily, which is why the school example was so great, because suspension is a temporary relief from school, right? Temporarily, but as gravity pulls on it, they fall to the bottom. That's why you have to shake those medicines, and that's why they're called suspensions, okay? Scale of 1 to 10 in the chat, how we're tracking on suspensions. Scale of 1 to 10. Okay, so it's a heterogeneous mixture. I see some 6s in there, a lot of 6s, so I'm gonna spend just a couple more seconds saying some things. The reason that suspensions and colloids are heterogeneous, different, I can visibly see the difference, right? The reason they're different is because you can see the particles, okay? You can see the particles, you can see the different portions, okay? Where they deviate, suspensions stay in the, like they stay up and they fall with gravity. Colloids are like pond water. So if you've ever seen pond water, you see all the flecks of stuff in it, you know, all the different little stuff, right? But they're so light that they're big enough to be distinguished, but they're small enough that gravity can't pull on them hard enough to counteract the displacement in the water, right? They stay suspended the whole time. A really good example of this is fog, okay, fog. So when you think of fog, it would be really weird if when your parents were driving, they ran over a fog puddle and it blew up into the air and then settled again. Like when you think fog, you don't think that, do you, right? When you think fog, what happens? There's a cloud of whatever, right? And it's staying there visibly in front of you higher, right? Those water droplets are staying up, okay? You drive through it, they're still up, okay? They may follow you a little bit because of draft and other physical forces happening, but gravity cannot pull them to the ground yet, okay? That's what a colloid means, okay? So suspensions, the particles can be seen and they fall. Colloids, the particles can be seen and they do not fall over time, okay? They do not fall over time. So, Ashlyn, are you here this morning or this afternoon? See, I keep saying morning. Oh my goodness, Ashlyn, it is not the morning. It is not the morning. It is the afternoon. Okay, Ashlyn, can you tell me, to the best of your understanding, the difference between a colloid and a suspension right now in your own beautiful words?
Okay, so a suspension, like, it has two different, like, substances in it, kind of, and, like gravity can pull on one of them, so, like, they look, like, separated, kind of, like, they look more separated, and then, like, a colloid still has two different, like, phases, I guess, but, like, the particles aren't big enough to be pulled on, so, like, they're still, like, it's so hard to explain, but they're, like,
no, you're good. You're doing a good job, and you were like 90% there, and I love hearing that process. So guys, when you guys say stuff, I don't care if it's 10,000% wrong. Every thought you have is valuable, because either it highlights a course of thinking that many students fall under and we can correct together, or it's demonstrating the concept. So everything you say is valuable and important in here. Every single thing. I don't care if it's right, wrong, sideways. If I ask you if that's purple and you say orange, I don't care. Like, I don't. We're not going to argue over what color the dress is. Like, that's not a thing. All opinions are valid, okay? But what I love that you said is you talked about in like two different phases. I love that, because to be a heterogeneous mixture, they are different phases. Homogeneous mixtures are same phase. That's why you can't see the difference, and they're evenly spread. When they're different phases like that, that's when you start seeing them. So I love that you said the word phase. I'm gonna like just shout that from the rooftops. Like if you were in the classroom, you'd be getting a sticker right now. Like, I'm so happy that you said the word phase, okay? I have lots of stickers, and we've talked about the stickers. You have the chance to earn a sticker today if you remind me later, okay? And when we do the Kahoot. But colloids and suspensions have particles. Colloids, gravity pulls on everything all the time. I want to clarify that. Gravity is a force that is constant, that we cannot change. Otherwise, you would fly off the set of, like, the earth, right? Like Mary Poppins style, like, bye, I did my job now. Like, that's not what happens. So gravity's always pulling. But for colloids, the particles are small enough that gravity can't pull it through the water. The force of the water pushing up is not as great, is greater than the force of gravity pulling down. Therefore, it stays suspended, okay? They're kind of neutralized. Whereas a suspension, the particles are big enough where the force of gravity pulling on them is greater than water pushing it up, okay? So water is pushing it up while it's going down. I know we're getting a little bit physicsy here, but as long as you understand that all sciences are really the same thing, we're just describing a different angle, then you'll see that all of them kind of bleed together anyway. I see something in the chat. I'm checking it right now. Okay, that's just people telling me how they feel. So colloids, the particles that are in the solution will fall or not fall. Suspensions is when they actually fall. So colloids don't fall, suspensions fall over time, okay? If they settle out over time like silt in a lake, that would be a suspension. If they don't settle out like fog, that is a colloid. Last thing, when you shine a light, okay, who's ever shined a light into a pond at night? Who's been camping and done that? Anybody? I know up north we shine frogs more than y'all do and stuff. Like I grew up north and we did lots of weird stuff because we're northerners, just to be clear, we're a little odd. But even like when you're driving, okay, what happens when a headlight hits a fog cloud? Anyone want to share without the wheel? Anyone be brave? Just unmute and say stuff. Okay, Amal, go.
You can just like see it more. I don't know how to explain it.
No, that's a great explanation. You see all the lights, right? Like you would think that the light was only where it was pointing, but all of a sudden it lights up the whole fog cloud. You can't see anything, and that's why it's so dangerous, right? It's the most dangerous road condition out there. What happens is those little particles, the light beam hits it, and it's like splitting it like this. And now you have two, like it's bouncing it and diffracting it all over the place, and they're bouncing around like ping pong balls, and all the lights like in the cloud like this. And that's what happens where it looks like the whole solution lights up. You see that here? Suspensions do that a little bit, but not nearly as much because the particles are big enough, they're more spread out. Okay, so there's not as much bouncing around. The example I would give is like the hallway, right? So when y'all are walking around the gym, you'd be like a suspension where you have particles, and if you guys were like at a school dance and you're mostly paired up, right? You're bigger at that moment and you're kind of spread out and you'll settle out and leave eventually. But like a colloid is like the hallway. If I tried to shoot something through the hallway like a beach ball while y'all were walking through the hallway, what would happen to that beach ball? It would hit tons of people, right? But if you had the beach ball in the gym, you might miss it. That's why colloids light up more than suspensions. Okay, does that make sense? Yeah? Okay, we're gonna do a Kahoot now. The reason I'm gonna do a Kahoot is because we're gonna reinforce the concepts, element, compound, etc. Some questions are gonna be text, some questions are gonna be pictures, okay? When you join with your name, because I'm checking against the attendance link for participation, okay? But let's see. Oh man, I pulled it up and I guess I accidentally X'd it out. Shame on me. Shame on Miss Longley. I should be more prepared. Okay, it's right here though. It's fine. I'll fix it in like 2 seconds. Are there any questions while I'm pulling this up and it's loading? Anything at all? Not even just like, what's your favorite color? On a scale of, what was I gonna say? I forget. Okay, classic. I'll turn this music off, trust me. It's like, ugh.
Your favorite color?
What's my favorite color? Like, I like turquoise and orange together. Like that complementary color thing going on. Big fan. Big fan. I also have a lot of yellow in my house. Mint green ion. No, it's not mint green. No, I have this mint green one because this is the one that costs the least. So when I went in Walmart, this one was cheaper than the one that was a different color. So I don't know why that was, but I got this one. Actually, my computer is turquoise as well. It's like that tealy turquoise kind of color. Yeah. So boop, boop. That's a good guess though, based on the information and data you have on me. Okay, I see 19 players. I should see 32 players. We will wait. Thank you guys for being interactive and asking good questions. Okay, we are waiting on 3 lovely humans. The pin will work for you.
I think I accidentally did it from my laptop, but then I realized that's not smart. So I need to redo it.
That's okay. Do you want me to boot you or do you want to get out?
Yeah.
Here we go. Go ahead. We'll get you. There will be technical difficulties from time to time. That is okay. Okay, the pin started working. Okie dokie. Just want to make sure. Now, this is where I said you have the chance to earn a sticker when you get back. I have vinyl stickers that I can spray with Lysol, and then you can pick one, right? So I'll spray with Lysol to be in class, and they'll be all disinfected, and then you can pick it yourself. So whoever wins today, if you remind me when you get back on campus, which for a couple of you is very soon, and a lot of you is not very soon, if you remind me, I'll let you pick a sticker out of my bucket. And they're all different types. They're not just sciencey stickers. They're all different things. Like there's superheroes, there's sci-fi, there's random weird unicorns with pandas saying hate is gonna hate. Like, I don't know. I have all sorts of different stuff. So yeah, it's cool. You will love it. Usually when you guys are in person, I have everyone have a composition journal, and all of the activities we do, you glue in and it becomes your notes. And then the stickers, people end up putting all over those, like bragging rights. Like, yeah, my science journal is stickered up. Look at this. Like that was the thing of the past, but we are in the year of COVID. All right. It looks like everybody's in. I love it. Okay. Starting right meow. Okay. Which classification of matter, which classifications are pure substances, or which one is a pure substance? Like, pick them all. Good, good, good. Dun, dun, dun. 5 seconds left. Good. Okay, so it looks like a little over half of you struggled with this, but the way it looks like you struggled is that you were thinking of element because it was a single atom, right? This is a common misconception. When we're looking at purity, we're talking about a single identity present. Okay, we're not talking about the types of atoms, but the single identity of the thing. So an element has either single atoms or molecules of atoms that have only one type of element present, right? One type of atom present. Those are considered, like if you have pure sodium, it's pure because there's only a single identity in your Petri dish or whatever you have, or your container, your beaker, whatever, right? For compounds, this is like table salt, okay? You still have only one type of thing in your salt shaker, hopefully, right? Hopefully there's not like other weird dark stuff in there. That's just sad. But if you have your salt shaker, it should be all sodium chloride. Every particle in that shaker has the same identity, even though sodium and chloride are chemically bonded together to form a completely new thing. Compounds form completely new identities when they bond. For example, chlorine gas will kill you, right? Everyone heard of Agent Orange? Okay, we're clear. Chlorine gas will kill you. Sodium is explosive. I mean, if you have a brick this big and you throw it in a lake and you don't throw it far enough, you are going to blow your face off. Like, it is explosive when it hits water, like will blow up your face. But yet you put it in your face every day when it's bonded with something else. So when you bond it, it completely changes it into a whole new thing, like transforming, like Jeff Goldblum in The Fly, which I know is a super old example, but if you get it, I'm going to know we're cool. Okay. So when you transform completely from one thing to another, that's what a compound is. It bonds and completely changes and now has a new identity and only has one type of identity throughout the substance. That's what we mean. Scale of 1 to 10 on the understanding there in the chat. And again, if you don't want to say a number publicly, you are more than welcome to say it privately. Just let me know. Okay, we are getting there. Love it. Okay, by the end of this, if we're still having problems, we'll talk some more, but we have lots of questions that'll help clarify and dig at this. If this is today's hard thing for you, remember it's going to be tomorrow's easy thing soon. If it's already today's easy thing, even better. Okay? Let me put a mask on. Oh, you're good. Thank you so much. They're delivering Virex, so y'all will be safe when you get here.
You needed both, right?
Yes, I needed both. Thank you so much. I appreciate you. See my cool mask that they gave me? Look at this, guys. Pretty snazzy. All right. Modeling good behavior, guys. Okay. So a material made of combined substances that each retain their own properties is a mixture. Yes, that is true. It is a mixture. Okay. So when they retain their own properties, I mean things like a chocolate chip cookie. Okay, if you were to take a toothpick and you were to take a little scoop of cookie, and you took another toothpick, you took a little scoop of chocolate. If you tasted those, would they taste the exact same? No, because they've retained their individuality. A good example of mixtures is you guys right now. If we were going to use you as an analogy, you in your houses on the screen, you are all pure substances, right? You are a single thing and you are the only thing in your container. When you come to school, you're going to be in a bigger container with lots of different identities, okay? You guys each still retain your personality, your physical attributes, what you look like, how you behave is the same as when you're home, hopefully, if you're true to who you are as a human, which you should aspire to be, right? But if you retain your personality, it's not like you come to school and then all of your personalities kind of meld and become a whole new personality and everybody acts exactly the same. You guys each retain your individuality and you're a mixture of student substances. Does that make sense? Okay. You retain the properties. Good, good, good. In a blank mixture, each substance can be easily distinguished. In which one can you see the difference? Heterogeneous, good. Heterogeneous, hetero means different. Easily distinguished, different. This is pizza, chocolate chip cookies, cereal bowls, anything that you can see, the salads, anything that you look at and go, yeah, that's a single thing, identify that as a salad, but there's all these different little things in it. That's heterogeneous, easily distinguishable. And a chemical level, it means there's pockets, okay? Pockets of different types of molecules where if you tested the properties of one part and tested the properties of another, they would be different, but it's still a single identity. You can see the difference, it's heterogeneous, okay? Granite rock is an example of what? Make sure you look at the picture. Make sure you look at the picture. Almost there. Good. Heterogeneous. We just talked about this. You can see the different specks. The fact that the specks are a different color mean they have a different physical property, which is color, right? They're retaining original properties even though they're mixed together in one slab. So that is heterogeneous. Beautiful. Okay. Most materials we use and encounter daily in our life are what? What are most of the things you interact with? What are most of the things you interact with? Okay, so wheel of names is spinning. Dakshin, if I say something wrong, please tell me because it will take me a minute.
Yeah, you said my name correctly.
Yes, Dakshin, okay. Why are most of the materials we encounter mixtures? Why is that true?
I got this question wrong, so I don't
That's
really
okay.
know.
Postulate what you think you may have done wrong, or tell me what your reasoning was for the wrong answer and we'll work through it together. Everything you say is valuable.
I thought it was compounds because most of like the stuff we interact with aren't like elements, and they're like a bunch of elements, so there'd be compounds like water and
Okay, let me ask you this. What's your desk made of? Look down at your desk in your house right now. What's it made of? What are you sitting at?
some like synthetic wood or something.
Yeah, so fake wood, right? Plywood, whatever it is. I'm guessing maybe IKEA furniture by that description, whatever, right? Is that a mixture or is that a compound?
A mixture.
Okay, so your computer, what do you think that is?
A bunch of parts and stuff, so that would be a mixture too.
Okay, what about your breakfast? What did you have for breakfast?
Cereal.
And what is that?
A mixture.
Okay, what are you breathing right now?
Air.
Right, and air is what?
a mixture of
Right.
compounds.
So I'm saying this because a lot of people don't think about things in these terms. This is completely new to you guys, right? So it's not like you walk around going, oh, look at this mixture right here. That looks great. That looks exciting, right? That's not how you think normally. This is totally new. So it's totally okay not to understand what you're interacting with and to think of it in this new way. So most things we interact with are mixtures, from what you drink to what you eat, to what you're breathing, to what you're sitting on, to what you're using, to the contacts you put in your eyes if you have them, to the glasses you sit on your face. Maybe you're blessed and don't have any eye issues, but those headphones you have on your head are also mixtures of things, right? Purity is rare. It is super rare. And if you want evidence, look at marketing. Okay, look at marketing. Think about any time you or your parents have been convinced to buy a $5 bottle of Fiji water instead of 99-cent Walmart water, which newsflash, by the way, there's a water plant in Rowlett that makes for both of those companies. It's the same plant. So you're paying $4 extra for the exact same water, just to let you know. I know because my friend runs the chemical plant there. But purity is marketed. You pay more for purity because in our bones, in our programming, in our social programming, we know that purity is not common. It's just we don't usually name our subconscious thoughts, right? We don't name our programming very often. But if you think about it, like even like jewelry, I don't personally wear jewelry and you won't see me wear any, but like when you see jewelry ads, they're like 24 karat pure diamond, beautiful, whatever. Like they're trying to get you to pay more money for something because it's rare. If it's marketed as rare, you understand that mixtures would be more common. Okay, does that make better sense to everyone? Because it was about half and half on that one. Okay, thank you, Dr. Sheen, for letting me pick on you. I appreciate you. Colloids and suspensions are what? We just went over this. Were you listening? We will see. Bum, bum, bum. Good, it's heterogeneous. Look at you guys. You are such good listeners. I love it, right? Heterogeneous, you can see the different parts, right? Suspensions, they fall. Colloids, they don't fall, but you can still see those particles. And you can see how light is affecting those particles. And those particles have a different identity than the water. And you're great. Love it. Easily distinguished particles. Okay, quiz. Question. In a blank mixture, this material has the same composition throughout. Same. Uniform, same. See how we do here. Good, homogeneous. That Latin prefix, homo, means same. Homonyms in English are words that sound the same but that are spelled different. Homogeneous are things that are same. Okay, homo means same. Okay. So same composition, uniform composition, homogeneous. The genus part is the composition part. The homo part is the same part. Okay? All righty. What is the following image an example of? What is an example of? Bum, bum, bum. All right, Andrew, the wheel has chosen you. Are you here? Yes, you are. I see you. Good afternoon, Andrew.
Yes.
How did you know that was an element?
Because I remember like gold is AU. Because like I forgot some dude was talking about it. I don't remember who. But
No,
yeah.
no, I love that. You literally said AU, which is fabulous, right? Where is AU found? Where do you see those letters?
Periodic table, yeah.
Yeah, the periodic table of elements, right? There's literally a whole table. So if you're trying to find if it's an element, look for it on the table. If it is not on the table, it is not an element. That simple. Okay, good job. Okay, that was not a trick question. You did perfect, Andrew. Thank you. Okay, next question. Which of the following is an example of a compound? Take a look at that picture, and I can tell it's smaller because all of you just did this. And it's really funny because all of your faces got bigger all of a sudden. But which of the following is a compound? Which of the following is a compound? Go ahead and answer. Make sure you do good guesses. Remember, I'm using this for participation, for attendance. Checking as the attendance link, and this is how you get to know if you know this information or not. Good, okay. Which of the following is an example of a compound? It would have been this guy, C. So the reason, I'm gonna walk you through these. What is A? Ashlyn, what is A? Wait, didn't you already talk? Did it pick you twice?
I did.
It picked you twice. Why? Oh, you're on my list twice. That's why. Garrett.
Yes, ma'am.
What is A and why?
An element,
How do you know it's an element?
because it's only one substance.
So what is B? Go ahead, Garrett, keep going.
An element.
Yeah, even though they're bonded together in molecular form, there's only one type of atom present, so it's also an element. C is the compound because it has two different types of atoms bonded together, but there's only one type of that binding that's happening. Every single particle in that square is blue-red. So therefore it's a pure compound of blue-red, okay? Beautiful, thank you for letting me pick on you, Garrett. All right. What is stainless steel an example of? Now this one's a toughie. This is one of the ones that we usually end up talking about. So if you aren't sure, you are with the most of the people, most of the students today. Came out really weird when I said it. Did not mean to do that. Yes, yes, it is a homogeneous mixture. So for those 11 of you that did great, I'm so happy and you're confident. Stainless steel is steel on the periodic table. I know more of you don't have it memorized, but the answer is no, it is not on the periodic table. Therefore, it cannot be an element, okay? When you're talking about different types of metals, when we mix them, they're called alloys, okay? Alloys, A-L-L-O-Y-S, hence the favorite cheesy joke. If Iron Man and Silver Surfer teamed up, what would they be? They would be alloys, right? Mixing metals, ha, ha. Corny joke of the day delivered. But mixtures of metals that are homogeneous, the way they make metals that are not on the periodic table is they melt two different types. They get them very hot. This is the basics of blacksmithing. You've seen in every single movie ever, right? That has blacksmithing. They melt them down. They mix them together while stupid hot. Then when they cool, it is a single metal that has a different ability to remain strong or not get stains or whatever it is. So stainless steel is a mixture of different types of metal that was done while it was in a liquid state. Okay, so it's evenly dispersed. Okay, that one was a toughie. You all did great. Okay, any material consisting of only one type of atom is what? There can only be one Highlander, guys. One type of atom. Okay, yes, it's an element. We're good. You guys did great. That's not me, guys. That is the other Elise that is in this class. I am not cheating and trying to give myself another sticker. I would just give myself a sticker if I wanted one, okay? All right, what can be separated by physical means? Good, a mixture. Anything you mix together, you can pull apart, even if it's difficult. Even salt water. If you've ever left a bowl out that had something salty, watery, like think ramen, I ate all the noodles, left a little bit of water in the end of the bowl, put it in my bedroom and left it there for my mom to find, right? Not that I'm bitter about my kids eating in their room, but when you find that bowl, it has little crusties on it, right? That's all the salt that stayed after the water evaporated off. So there are ways to separate things even that you can't physically see, but you can still separate them without using a chemical reaction, okay? A compound is represented by what? What is a compound represented by? All right, good job, guys. A chemical formula. The word formula relates to the fact that compounds have a mathematical ratio, whole number ratio relationship. That's why the word formula is there. It is made of chemicals, hence the word chemical being there. So it's different atoms in a formula stuck together. Okay, that's a compound. All right. What is the image an example of? What is the image an example of? Is an example of what you ate for lunch. Did you guys have a better lunch than I did? Mine was all vegetables and chicken. It was not as exciting. Good. It is a heterogeneous mixture. Hetero meaning different parts. The cheese and the pepperoni taste different together. The crust tastes different. If these things didn't taste different and it was a compound, then there would be no point in ordering toppings on pizza, right? You wouldn't. And if you, if there was like a pizza compound, it'd be like all those particles combined and formed a whole new identity, but that's not the case. We're retaining our cheese molecules and our pepperoni molecules, and they taste different, and it's wonderful. If I made that pizza, there'd be pineapple on it, but I know that's very controversial. Okay, when different atoms combine in whole number ratios, what are formed? I feel like I've said this 10,000 times, so let's see if we're listening. Hopefully this is becoming an easier thing with each question. Yeah, I wish that was my lunch too. I love reading the chat. Good. These are compounds, whole number ratios. When you see that, think compound, chemical formulas, whole number ratios. They all relate together, okay? They all relate. All right. Salt water is an example of what? What is salt water an example of? Good. It's a homogeneous mixture. Why is it a homogeneous mixture? So I see that a lot of you were struggling with this one. A lot of you picked heterogeneous. Why did we pick heterogeneous, do we think? Someone who picked heterogeneous and is feeling really brave, can you tell me why you picked that one so I can help the others? I want to know what your thought process was.
I didn't pick it, but maybe because it's sometimes when the salt isn't completely mixed in, you could kind of still see it like floating there.
Yeah, that would be a super saturated or an oversaturated solution. So when you have more solute than the solution can absorb, it stays in the bottom, but the actual water itself is still homogeneous. So was that most, thumbs up if that was most of you. I just want to make sure I correct the type of thought that's happening here so that way we can be successful in the future. Or you can drop it in the chat if you still have a question. You can drop it to me privately. But salt water is when you have a like ocean water that's pure ocean water, or the sea water itself, just the water, not all the other stuff in it, right? You see just the salt and just the water, okay? You know that salt is there because you can taste it. You know that water is there because it's aqueous, and this is where aqueous solution comes in. But they are not chemically bound. There's not a salt water molecule, okay? There was water and there was salt, okay? And we know they both exist because we can see both of their properties with our tongue and see it and physically, but you can't see the difference, okay? I see that some of you are telling me that the picture was confusing because the light passing through in the bubbles. So if that was the case, I'm sorry, but make sure you know that the actual water itself was homogeneous, okay? All right. 3 questions left, guys. Which of the following is an example of an element? Which one's an element? We went through this one. Go ahead, if you are being fearful, pick your answer, commit. Good, look at you guys go. Love that. A and B, because there's only one type of atom present, represented by color. There's only one color present, that's only one type of atom present. Good job, lovely human. See, today's hard thing is already becoming an easier thing. Not tomorrow's easy thing, it's gonna be today's later easy thing. Okay, what's the difference between an element and a compound? Yeah, compounds are made of more than one type of atom, and we've gone over that a few times. So 19, what is air an example of? What is air an example of? Ignore the cloud part, just think of the air part, like the air in front of your face. Okay, this is homogeneous. For the 11 people who struggled, let me give you an example of what it would be like if air was heterogeneous. Are you ready? If air was heterogeneous, when you walk through the hallways, you would have pockets of oxygen, pockets of carbon dioxide, pockets of nitrogen. So you'd be walking from like walking to G hall to get to my class, you know, the gross hall that smells funny. And you're walking, and all of a sudden you hit a pocket of nitrogen. You're like, you can't breathe. And your friend's like, oh my God, she hit the nitrogen. And they grab you by the ankles and they pull you back into the oxygen. And then you breathe and you're like, okay, I'm in the oxygen pocket. And then you would walk again. You're like, oh no, now I hit carbon dioxide. And you pass out because, you know, asphyxiation's a thing. And they pull you back into the oxygen pockets. And it would feel natural to actually navigate life and where you walk based on oxygen pockets. That's what heterogeneous air would be like. That is not the case, right? We breathe and we have an even mixture of oxygen, nitrogen, carbon dioxide, and all the other little atoms, you know, little gases that are in air, and they happen evenly, okay? Air is literally punching you in the face right now. If you want proof, go like this, okay? If you feel the air on your hand, that is air molecules punching your hand, okay? You walk through a solution every day. You literally live in solution. Like, if you could see air, it would look like you're walking through the ocean all day. You are literally walking through molecules your entire life, okay? Radio waves, all of it, energy is all hitting you in the face all day, okay? So we have a homogeneous mixture, which is the solution that we live in, not like the solution, like the answer to the problem, but you literally live in a solution, okay? Last question, let's see who gets a sticker. What is table salt an example of? What is table salt an example of? Good. It is a compound. There is a sodium and there's a chloride, and they have hooked up with a chemical bond forever. And if you have a salt shaker, you should only have salt molecules in that shaker, right? It's the same identity of every particle, even though there's more than one atom present, because they're bound together. Sodium, right? We've talked about the sodium explodes and explodes your face. Chlorine gas, right? Would kill you. But when you bind them together, it's yummy on food, unless you put too much, and then it's not yummy, okay? So let's see who gets the sticker. Okay, Ashlyn, you're so close. Maybe next time. Ethan, you are closer. Maybe next time. This is so dramatic, okay? Yay, I get a sticker. Nah, just kidding. Elise, if you remind me, I'll give you a sticker when you get in here, okay? All righty, guys. So the last little bit of class is just a couple admin reminders. The first thing, what do you have to do right now? Where do you look to find what you have to do? Oh, no, not that one, this one. Where do you look to find what you have to do?
Learning plan.
The learning plan, okay? So you guys are in that funky space where technically it's the 3rd week, right? But you guys are still on the end of week 2 because you're the B day to the 28th, right? So at the end of the 2nd weekly learning plan, okay, weekly learning plan 2, you see this. You're supposed to be completing QC 1.4 today. I will be taking a grade for those tomorrow and putting them in. If it's not there, it'll be 0 marked missing until you turn it in, okay? I don't play the game. If you guys have missing stuff right now, please turn it in ASAP, okay? I wanna make sure y'all get credit. I know the first few weeks were crazy and I'm allowing for that space of craziness. So please turn them in soon because I will not let that happen at the end of the 9-week period, okay? Turn them in as soon as possible. You also need to do one of the classification of matter activities, either the 14 chemicals or a matter scavenger hunt in your house where you find things, okay? That's been the popular one of the day. It's actually kind of fun, okay? So these are the 2 things you have to do right now. Before next class, you need to watch those video notes, okay? They're right here. You'll see it's also on the beginning of this learning plan that you have to do the video notes. It doesn't have the async thing though. That's why I said I want you guys to look at the 2nd week plan. This is where the links are, okay? Make sure you know where you're looking, okay? All right. That is where, so hold on, let me chat. Yep, the learning plan, someone texted that. Okay, so I have one last thing for you to sign off, but it's specific to me.